Today we're going to be transforming the graphs of the trig function. So sine, cosine, and tangent, we're going to see how they can be translated, reflected, stretched. Okay. What we're going to do is look at the standard form of the rules for these functions and indicate what relationship the letters have with the graph of the function. And to begin with, we're going to say that the amplitude of a function written in this format is the absolute value of a. I have to say absolute value because if it's positive, that means that it will operate the way the normal sine function does, which is go up and then come back down. If it happens to be negative, it will start going the opposite direction, down. But the amplitude is how much it varies from some midline. So if you think about this, the normal sine function does this thing with an amplitude, or the highest that it goes is 1, right? 1 above to 1 below. If we vary this, we can make it go taller and deeper, right? Or shallower if we so desire. But it's the absolute value is the amplitude, and that tells you how far it varies from the midline. The midline for a normal one is at x or y equals 0, but if we mess with the rule at all, the midline becomes d. So this is the vertical shift. If the midline goes up, then of course that whole function has to go up. The period for sine is 2 pi if nobody's messed with the rule. But if they've messed with the rule, it's 2 pi divided by b. So 2 pi divided by that multiplier. Notice that that's inside the parenthesis. Phase shift is left to right translation. And the C is the letter that's associated with that. The amount of the phase shift, though, is C divided by B. Okay. In the cosine, things are exactly the same way. Sine and cosine are very much alike. Absolute value of A, 2 pi over B, C over B, and D is the vertical shift. Just a note. Notice that that sign inside the parenthesis is minus. The phase shift, though, if you have a minus in here, that means you're moving to the right. If you have a plus in there, it means it's been moved to the left. It's just the same way that other functions work. The tangent is very similar, except amplitude doesn't make a whole lot of sense here, since tangent curves can go very high and very low. There's no boundary to them up and down. The period, though, of a tangent function can be affected. Normally it's pi, but if the rule has been doctored, pi over b. The phase shift, again, that's c over b. And the vertical shift, that is the midline at d. So now we've got the basic structure for all of these transformations. Let's see how that plays out for us. We are to state the amplitude and period for the function y equals 3 times sine of 2 theta. Then we're supposed to graph one cycle of it. The amplitude is the number out in front, 3. So I'm going to go to my graph right now. I'm going to put a -3 here and a +3 here because this baby is going to be taller than normal. To find the period, we know that the period is 2 pi over b, and in this case, b is 2. So that means our period is pi. This is going to get done with one full cycle in pi radians. And now I'll show you the trick that I do. Oh, there's no vertical shift and there's no phase shift. I know that you can graph the sine and cosine in 4 steps, right? 4 steps. So if I make this pi, that would make this half of it, or pi halves. Now I'm good to graph my sine wave, realizing that sine follows the pattern 0 max, 0 min, 0. Okay, so sine function starts at 0. It hits its max, and in this case the max is 3 because the amplitude has been changed. Then it's 0, min, and back to 0. And when we draw in our smooth wave, we will have graphed one cycle. Voila! Alright, let's see if we can do this. Write an equation of a sine function with amplitude of 6.7, so that's the A, and period of 3 pi. Okay, you know, that period, well, let's just get started here. Y will equal, amplitude is 6.7, and it was positive, so it's going the regular way. 6.7, and then it's the sine of, okay, here's where it gets weird. We know the period, and we know that the rule says the period is 2 pi over b. What we need, you guys, is b, right? 3 pi is the period, so 3 pi must be the same thing as 2 pi divided by b. And to find b, which is what we need for our equation, we have to multiply first by it, get it off of the basement, if you will. And then it's divide. B would equal, we're going to divide by 3 pi. 2 pi over 3 pi, and the pi's cancel. So b is 2/3. 2/3 theta. There is no phase shift, no vertical shift. So here's our equation. Y equals 6.7 sine of 2/3 theta. All right, good. Let's see if we can do that again. We're going to graph y equals the sine of theta plus pi. Okay, amplitude is 1. There is no amplitude other than 1. The period is 2 pi over b, so a is 1, b is also 1. There's no multiplier in there. So the period is 2 pi over 1, or just 2 pi. But we do have a phase shift. So the phase shift, that's left and right translation, that is equal to c, which in this case is negative pi, over b, which was 1. So our phase shift is negative pi, that is, it's been moved to the left pi radians. Alright, now this time the graph paper is not marked for you, but I still know that we're going to get done with a full cycle in 2 pi. It's just that our cycle is going to be shifted to the left. I am going to let 2 squares here equal a pi halves, so that's negative pi halves. There's negative pi. Here's pi halves. Here's pi. Here's 3 pi halves. And here's 2 pi. Since you're graphing, you get to make the scale, and it is in your benefit to make it advantageous to you. Now, we have to move everything in the sine wave back pi to the left. So this is the place where I'm going to start my cycle. I still follow the sine pattern, which is 0 max, 0 min, 0. And I think to myself, I have to be done in 2 pi. So this is where I got to end up. And I do things in fourths from there. So 0 max, 0 min, and back to 0. There's our full cycle of this particular wave. This one's got it all, y'all. This is going to be a little bit trickier. I just have that feeling. We have an amplitude of 2. We have a vertical shift down 1. And that means instead of using as a baseline the axis that we're used to, everything is being shifted down. So when I graph this, that's the first thing I do. That's going to be my baseline. Okay? The period on this one will be 2 pi divided by b, which is 2. So the period is pi radians. And the phase shift in this one is going to be pi halves divided by b, which is 2. Dividing by 2 over 1 is like multiplying by 1 over 2. That means we are moving pi fourths to the right. Okay. Alright, so if I make this guy be pi fourths, and I'm going to just write that up here, pi fourths, that would mean that this is 2 of those, pi halves. There's 3 pi fourths right there, and here's pi 4 pi fourths. So out here would be 2 pi. And let's see if we can't graph this thing. This is a cosine wave, and cosine starts at its high point. So the pattern is max to 0 to min to 0 back to max. And let's see, we're going to get done at pi radians. So if we're starting at pi fourths, then out here at 5 pi fourths ought to be where we stop. So let's see if we can put it all together. We have an amplitude of 2, a vertical shift of -1, and our starting place is pi fourths to the right. Here's our baseline. We start at the maximum, and the maximum has been, the amplitude is 2, so here's the maximum. At the next point in this, and remember we're going to end up back there, right there. The next point for cosine goes to the 0, or to the baseline, right, the midline, right there. Then it goes to a minimum, back to the baseline, and up. And here comes one cycle of that curve. Ladies and gentlemen, that's kind of interesting. Remembering the patterns, that min 0, max, that stuff is going to be very helpful to you. Identifying how long one full cycle is going to take is imperative. Okay, we got to know that. And then just remembering that you can break that cycle up into 4 pieces, literally 1, 2, 3, 4, right? 1, 2, 3, 4. It's not as difficult to graph these as you might think. Let's move on to our last thing. And our last activity asks us to write the equation of a sine wave whose amplitude is 4, whose period is pi, and we remember that period is equal to 2 pi for sine over b, whose phase shift is -pi8, and we remember that phase shift is equal to the c over b. So we have got to find ourselves values for c and b, and we have a vertical shift of 6, so that means our d is +6. All right, let's see. Let's go after the period first. The period of our wave is given to be pi, but I know that that has to be 2 pi divided by b, and b is the thing I need. So I multiply by b, then to find b I want to divide by pi, so b will equal 2 pi over pi. Pi's cancel and b is 2. Alright, that's good news. Let's find c. The phase shift in this one is -pi over 8, and that has to equal, folks, c over b. Well, we just found b to be 2. This is a proportion, so I'm going to cross multiply. 8c will equal -2 pi, and divide to get c. That's -2 pi over 8, or -pi fourths. All right, I believe we have a value for A, a value for B, a value for C, and a value for D. We're ready to write this. How about y equals, and it's A first, that's the amplitude. It was a sine wave, so 4 sine, and we do have both phase shift and period change here, so we need the parentheses. It's b times theta, and b is 2, so 2 theta, and then phase shift, or c, is -pi fourths, so this is really minus pi fourths, and then +6, and of course, you know, you can simplify that. 4 sine of 2 theta plus pi over 4 plus 6, and there's our equation. We had to go after a value for B and for C, and we did it very well. Good. Lots to think about here. Get out there, try that, you try, and we'll see you in class.